Ready-made maths YouTube training videos. Teacher and teaching assistant mathematics training. This week is master it in place value, and we're now up to day 4. There's two parts to today. Part 1 is greater depth using base 10. This is going to be quite a detailed look at how we can really build up a real picture of two-digit numbers through the use of base 10 and using it in a far deeper way than just laying it out as the number of tens and the number of ones. There's going to be lots and lots of manipulation today. As with the majority of the week, we will be spending virtually this whole session in the Ready-Made Maths classroom, looking at the different ways that base 10 can be manipulated. Just to quickly go through the program for the week, on the first day, we looked at real place value, looking at 4-digit numbers and all the different ways that they can be discussed. That developed in day 2 into really looking at ones and tens and hundreds. Yesterday, on day 3, there was two videos, one longer one on a visual understanding of 2-digit numbers using tens frames and using Numicon, amongst other resources, and a shorter video which links into what we're about to do now on the place value number grid, the sense of number 1 to 120 number grid, which shows a visual picture of numbers up to 120 rather than just a standard 100 square image. As you can see today, we've got the main video on looking at base 10, and then a shorter video on 5 and a bit that I have been referencing throughout the week and in many, many other training sessions as well. So I hope you enjoy the training and hopefully you'll find many, many useful ideas. What we will be using throughout some of the sessions today is a few images from the sense of number visual place value policy. This is a series of A3 wall charts that can be purchased from Sense of Number. They will be obviously adapted for your school. They've been designed by Dave Godfrey and worked on by the Sense of Number mathematics team. The aim of these is to give a real visual picture of place value in as many ways as possible. There are two elements to the place value policy. There are the wall charts and there are some other images that come as a separate folder. As you can see, just a very, very quick one. This actually links back completely to day 5 of the early years training, the final day of the early years training, when we actually looked at the number 6 in as many ways as possible. This is a lovely, lovely poster for place value of 6, where you can see the number 6 set out and arranged and visualized in lots and lots of different ways. Some of those are ones we're very familiar with. We can see here the 5 and 1 image, which I'm going to be using an awful lot today, which links to the fingers image, which we talked a lot about on the early years training. We've got a Numicon piece, which gives you the kind of the double 3 or the 3 2s, or the array image, which is then replicated here, but turned the other way where you look at the chipmunks. Again, the tens frame, look at the link there between the tens frame, 6, and the base 10, 6. They are set out in that same way. They're not 6 in a straight line, they are 6 as 5 and 1. Similarly, you'll see the place value counters set out exactly the same way here. Interestingly, the abacus or the number frame image that you can see at the top, not the number frame, the abacus or the bead bar, sorry, that you can see at the top, you will also see 5 and 1 due to the color change. So there's a range of different images as well as the numeral and as well as the word 6. Later in the second part of the video today, we will be looking at some bigger numbers and how they can be visualized and arranged in different ways. I also just want to reflect on something we looked at earlier in the week. I should have actually included this as part of the training on that particular video, but I just thought it is worth referencing just as a quick reminder of what we looked at on day 2. We looked at that number 1,000. 1,000 is 10 hundreds, 100 tens, and 1,000 ones. We looked at the number fun song that linked to that. But this is just an amazing image of 1,000, where you can physically, visually see the 1,000 ones. They are all there on the screen. You can see them all individually if you wanted to count them all. But you can do a lot of reasoning just using this poster. This is 1,000. Why? That's one whole 1,000. It's made up of 10 separate hundreds. There's 5 on the top and 5 on the bottom. We just looked at 1,000, sorry, 100, sorry, using Numicon. I don't have enough pieces to create 1,000. But you can also see there are 100 tens, because there are 10 tens in the first 100, 20 tens, 30 tens, 40 tens. Again, we looked at all of that with base 10, but I think it's really nice to see that as a picture with Numicon as well. So that's a really nice reasoning poster that can be played around with the children in maybe year 3 possibly. Again, that one is the sort of activity that we did using the song, What Do You Know About a Number? Again, on the song earlier in the week, we looked at 2,638 with base 10. Now you're seeing the same number, but created with Numicon. There's 1,000, there's another 1,000, massive numbers there. There's 600, again as a 5 and a 1, 500 and 100. There's my 30, which is 3 tens, and there's my 8 piece. And there, that was what we talked about in the song earlier on in the week, the different ways that we can talk about a number. So, as I say, I'm not going to go over all that again. Please, if that's something that you find interesting and you've not seen day 2, do have a look back at day 2. And obviously, look at day 2 in conjunction with this particular poster from the place value policy. Good morning and welcome to day 4 of the Ready Made Maths YouTube training videos for this week. This week we are looking at place value. And we've actually kind of almost gone backwards throughout the week. We started off with 4-digit numbers. We developed that into 3. Yesterday we looked at tens and ones and the ones value in specific numbers. We're continuing that today. It's very much a Key Stage 1 focus day, but looking in depth at numbers in Key Stage 1. What I want to try and move away from, as we talked about yesterday, is just the idea of 32 is 3 tens and 2 ones, and that's it. You know, we want to look at it in a lot more depth. Yesterday it was particularly multiples of 10 that we're focusing on, whereas today we're looking more at any 2-digit number. So you'll notice on the table, as we kind of focused on right at the end yesterday, you'll see first of all up here, you'll see the TTS number tiles, which absolutely love this resource. Really colourful, really pictorial, and again one that I used a lot last year in many schools. In front of that, again using the same colour scheme, these again come from TTS because they match the tiles. These are the base 10 numbers. Now you might notice, and I'm going to focus on these in a lot more detail shortly, you might notice that the numbers that you're looking at are set out in very different ways. They're all using base 10. You can see, you know, lots and lots of different numbers on there using base 10, but they are all set out quite differently. So, if I can just explain what we're going to be doing over the course of this session. We're going to start off looking at base 10, and we're going to look at, you know, what's the best way of setting it out, but let's look at some good ways to lay out base 10 so that you can see the numbers straight away. Let's also look at how base 10 can link into a different image and give children a real understanding of where each of the numbers is in the number system up to 100. What we're also going to then do is we're going to move on from base 10. We're going to look at a range of resources today and look at how we can lay things out really effectively so that even as numbers get bigger and bigger, they can be read really easily because of the way that we lay them out. We're going to be looking at 5 and a bit. As we've mentioned many times before, looking at the Ready Made Maths number board that we've been using for the last few weeks, what I've done today is I've selected a range of different numbers from the board, taken them from the main board and put them up here onto the whiteboard. What I want us to do is to focus on those numbers, and if we just kind of home in on 1 or 2 of the numbers, if we look at the number 45, for example, we've mentioned before that there are other images that surround it. We've not really taken much time to look at them, but around the number 45 are some other images. We've got the 5 and the 9, which is part of the multiplication. 5 multiplied by 9 is 45. We've got an abacus image here, which is actually 5 9 times is 45. We're not really looking at those today, but down here on the left of each of the numbers, we do have the base 10 image. So if you are in a school that's using the sense of number reasoning cards, rather than just having standard 2-digit number cards, the children have actually got a picture that supports their understanding of the image. As they're looking at 45, they're seeing 4 tens and 5 ones. As they're looking at 88, they're seeing 8 tens and 8 ones, and they're seeing how close it is to the next 10. You can see it's only 2 away from the next 10. As we're looking at 55, we're seeing 5 tens, we're seeing 5 ones, and we can see we're almost, we are halfway there to the next 10. Whereas with 71, it might not be as clear that there are 7 tens there. We can definitely see the 1, but we can see that there are, you know, quite a lot of tens there. If we count them, you will get to 7 tens. Later on today, we're going to look at a slightly better way of arranging base 10, just so it's easier to see the 90, easier to see the 70, and so on. But it's just nice to have an image when you're looking at a number. So what we're going to do now is we're going to take all of those numbers, and I've made every single one of those numbers back on the table. What we're going to do now is look at them, look at the different arrangements, and see which of them are the most effective.
Just to focus in on 4 of the numbers there, so you can see the at the base 10 much clearer now. You can see the 55, the 33, the 45 and the 12. And you can clearly see now, I'm going to have a home in straight away on the 45. You can see the 4 10s and 5 1s. It will just go slightly further up to the 88. Again, it's much clearer now. You can see the 8 10s and the 8 1s. We're going to look now on the table and we're going to see those numbers specifically. What I've now done is I've moved the base 10 that we looked at earlier on. I've set them all up so it's much easier to see on the camera. You can get them all into one shot. Really interested in getting people's opinion on this. So if you can get back to me on this, it'd be really interesting to see which of these you found the easiest to read. But I've basically created all of the numbers, all 12 numbers that were up on the board earlier. I'd like to pause the video and spend a while this time just looking at each of those numbers. Which of them can you instantly look at and go, yep, can recognise that number straight away? Which of them take you a little bit longer, but very, very quickly you can work out what the numbers are. And which of them take the longest? Which of them actually you look at, you've almost got to count them individually so you know the number. So take time, pause the video, look at every single number that you can see on there, jot them down, and then we'll double check together what each of the numbers are. Let's take a look at the first 6 images and see which ones were relatively easy to see. I would imagine that this one here was relatively easy to see. It's the smallest number, it's 2 10s and a 1, it's 21. Probably just instantly recognise that one. But looking at the others, I think there's some of them that are much easier to recognise than others. Let's move, for example, to this one here. What number do we see? 45. How do we know? Straight away we can see the 4 10s, we don't have to count them. There's 2 10s and 2 10s. And we can see a 5 set out in a dice formation. Now that isn't normally the way that people would set base 10 out, but it does make it easy to see the number. We're going to move on to other ways that I think are preferable, but it's quite interesting that if a child was to set them out that way, you would be able to see the number instantly. I'm going to talk later, as I say, about more effective ways. Let's look at some of the others. Well, this one here, we can definitely see the ones, there's one of them, but we don't see instantly how many 10s there are. Moving to the one at the bottom, I think that one's quite an interesting way to set them out. I like that approach. What can I see there? Well, the 2 10s stand out straight away. I can see those. They're less than 5, so my brain just tells me there are 2. The next number, though, has been set out in that 5 and a bit style that we're going to refer to later. I can look at that and immediately go 29. I can see it's 29 because it's 1 away from filling the 10s frame. It's like 1 less than 10. So I know it's 30, subtract 1. That same approach applies over here. We can see the 3 10s because there's less than 5, so we can see the 3 straight away. But we can also see the 7. Just imagine, as we'll see on some of the others, if those 7 were in a straight line. You'll have to count them individually. So again, 37, straight away. If we look directly above it, that's one of the examples that I was referring to. You can see probably relatively quickly that there are 6 1s, because you can almost use your brain to look at them and separate them into double 3, but I think a lot of children would look at that and would instantly have to count 1, 2, 3, 4, 5, 6 because they're in that straight line. Similarly with the 10s, there are 6 10s. We can probably get there quick, 2 4 6 or 3 6, but it does involve, you can't instantly see the 6, and certainly with the number above. If we put them next to each other, we can see there's 1 extra 10, but if that was on its own up here and it wasn't linked to any of the others, you'd look at it and you'd have to count those 10s. As soon as you separate them, it does make it easier. So again, that's our image of 71. Let's move over. This is where it does get interesting. You've got quite a few different numbers there. Separate, let's put it on straight as it was before. Again, the number 12 jumps out straight away. We can see that one. Let's look at the other 6 numbers that are arranged on the table. Well, this one, because it's a small number, it is in straight lines. It's not set out the normal way though. We've been looking vertically. Suddenly this one's horizontal. It's set out 3 10s and 3 1s, and the 1s are above the 10s. But again, it's an easy number to see. 3 10s and 3 1s, 33. What about the rest? You know, how easy are the others? Well, again, what I've tried to do is mix and match the layout this time. The first 6 were all vertical. The 10s were all set out in a vertical arrangement as most children and most adults. It was the 1s that were arranged very, very differently. Over here, I've just mixed and matched the whole thing. The first two over here, I've got the 10s in a vertical arrangement, but this one, and this one, and certainly this one look very different. So let's start with the ones that are a bit easier at the bottom. Why is that one easier? Just simply because I separated the 10s into 30 and 30. 30, 60, 4. The 4 is in a dice image. If you saw any of the early years training last week, you'll have noticed how we talked a lot about just arranging things in a way that makes them easy to see. There are certain arrangements that are better than others, but that one is a very straightforward dice image of 4. Moving up, again, this one shouldn't take too long because again, it's 5. So there are 5 tens. You might, because if they're separated a little bit from each other, so they don't all just join together, that 5 can be seen quite clearly. 50, 5, 5 tens and 5 ones. But just imagine as we move over, if we'd have done that. If we'd have done that straight away, we're struggling now to see how many tens there are. As soon as I separate them, 50, 80, 5 and 3. So this to me is the absolutely ideal image of how to represent a number with base 10. I've separated the 10s, 50 and 30. I've separated the 1s, 5 and 3. It takes a fraction of a second in year 2 when you're used to doing it this way to go 50, 85, 88. As opposed to the one above, which is far smaller a number. If you look at those two, I think that probably is one of the, is a harder number to read than this one. You need to use your place value sense. 4 tens and how many ones? Well, you either count them individually, or luckily, because I've put them next to the 10, you can see that there's 2 short of being 50, so it's going to be 48. There's so much maths that goes on just in that activity. I could spend 2 days easily just playing around with arranging base 10 in different ways, talking to the children, discussing the different images, just asking them to talk about how they've arranged them, which are the efficient methods, which are really effective, and which are actually a little bit hard to actually see the numbers. And I always find, especially with the 10s, the second those 10s are put together, it just makes it so much more difficult to read the number. That brings me to the final image, which is very, very random. Now, actually, it might be easier to read, funnily enough, than the ones that are joined together, simply because your brain can almost instantly partition them into sections. There's 3 10s, there's 3 10s, and there's 3 10s, or 2 10s, 2 10s, 2 10s, 2 10s, and 1 10. So in some ways, that's easier than just putting them in a straight line, but it's not very well structured, it's not very well organised, so we do need to develop children away from just randomly putting them on a table. That is the number 97. There are 9 10s and 7 1s. And again, that 7 1s, if children are taught to subbutise well in early years, they'll look at that and go, actually, rather than having to count in ones, we'll possibly go, I've got a 3 there and a 3 there and a 1 in the middle, or I've got a 4 and a 3, or whatever other way they see those ones. But what we could really do with doing, as we're going to talk about later, is just having an efficient way that very quickly everybody can use. So I'm going to rearrange those now into a relatively simple, hopefully, way to represent 97. And again, later in this session, towards the end, we're going to develop that particular image. 50, 90, 5 and 2. 9 10s and 7 1s. Or, if I do it that way, the same idea. 9 10s and 7 1s at 97. So we've just looked at how base 10 can be arranged in many, many different ways. And I do think there's a real value to doing that, to allowing children that real opportunity to play with the numbers. Just to, any number cards, to turn them over, get a number, now show me that number. Can your friends see it straight away? Can they tell what number you've got? Can they use an arrangement that they're familiar with? And initially just let them play. Don't specify a particular arrangement that you want the children to use. Let them play, let them arrange them. And the children that do kind of put them together randomly or put them together always in a straight line, as the numbers get bigger, you will find it's much more difficult to read. Having said that, certain resources, such as the 120 number grid we looked at yesterday, and the TTS number tiles that we're about to look at now, they do use that arrangement, but in a way they have to because of the restrictions of the space in which they've got to actually create the resource. And actually, in this instance, it doesn't matter as much because the numeral is there. It tells you what the number is. You can see the number, and so really it becomes more of a reasoning resource and something you can develop a lot of mathematical understanding with. I've deliberately arranged these numbers very, very randomly on the table, but I would often do activities where, it's a shame, obviously, because we're doing a training video with myself on my own. I use these loads in class where I give children one of these cards each. And I have them moving around the room and talking to each other and discussing. For example, one child has this card and one child has this card, and they compare the 2 cards and look at them. I've got what number? 63. I've got 66. Well, I've got 6 10s. I've got 6 10s. I've got 3 1s. I've got 6 1s. I'm smaller, I'm greater, and so on. my number is worth 3 more than your number, or my number is worth 3 less than your number, and so on. So we do a lot of that sort of activity. But often, again, just having these on the floor and allowing the children to look at them and just talk about the difference between different numbers that are next to each other. You know, what do you notice when you look at this one next to this one? Well, this particular number, the 2, only has 1s. This one has 10s and 1s. This one has got an extra 10 and an extra 3 1s. So the children can actually see the visual difference between 2 and 15. They've got a difference of 13. Now, that's not really a place value activity, but it's place value being developed into addition and subtraction. But there are some numbers, if I was to just try to find the ones that have similar numbers of 1s, again, if I was to just put these two numbers next to each other, again, just look at the value there, just having those two next to each other. What number is this? 28. How do I know it's 28? It's 2 10s and 8 1s. What else can you tell me about 28? It's 2 less than 30. If I put another 2 on, that will get me to 30 or 3 10s. Have a look at the number underneath. What number is that? Well, that's the number 58. That's got 5 10s and 8 1s. So again, really nice to have those two things as well, 5 10s and 8 1s. And that one's 2 away from 60, or 2 away from 6 10s. Now let's compare them. And again, if I look at them, I can almost put them on top of each other there. With the 10s, I can see there are 2 10s that are the same, and then there's an extra 3 10s. In the same way that 2 and 5 have a difference of 3, 20 and 50 have a difference of 3 10s. So again, really, really nice to ask the children to see that. So we can go either way. Again, if I was to take the 58 and the 66, again, great numbers to have next to each other. Do I put them, you know, one there and one there to compare, or do I put them next to each other that way to compare? Well, let's look at the two numbers. This one has got 5 10s and 8 1s, and this one's got 6 10s and 6 1s. So this one has got more 10s, but this one has got more 1s. What's the difference between them? Well, you can see that this one's bigger. You can definitely see that it's bigger. Why? Because it's got more 10s. If I put them next to each other like that, you can definitely see it's bigger with the extra 10s that it has. But how much bigger is it? Well, looking at this, I can almost see, if I was to put another one there, I'll get these ones that are a little bit, you know, there you go. Put those 2 1s there, that gets me up to 6 10s, and then all I need then is an extra 6 1s, and obviously that will get me to 66. So I can have another 8, and that will get me to the same number. There's hundreds of activities you can do with these, and what's also really nice, as with the 120 grid, is the numbers do go beyond 100. What makes this one different, or this one different to all the other numbers? Let's put those two here. I can see here I've got the number 104. 104 ones, but as we said yesterday, there's no red. There's red all over the place. Oops. But there's no red on this particular number. Why? Because there are no 10s. 104 ones. No 10s, but it's 104. We've got to put the 0 in as a placeholder, otherwise it will be the number 14. It's definitely not the number 14 because there's 100 there and 4 here. So again, it supports it. It's not just a 100 square with no value to the numbers. Here again, we have 101. And again, lovely. Let's look at the difference between those two numbers. We've got 104, 100, no 10s and 4 1s. And up here, 114, 100, 110 and 4 1s. Again, looking at the numbers next to each other, we can clearly see that this one has got an extra 10. There is the extra 10. That's got no 10s. And that's got 110, but it now means something. I can see the number that's being represented. They both, what's the same, what's different? Well, they both got 100, they both got 4 1s, but this one's got an extra 10. As I say, I could spend, you know, an hour. In fact, last year, when I was working in the school in Salford, as I mentioned yesterday, I went into year 1. I took a big group of year 1 children into the hall. We had all of these set out, and we did, you know, half an hour to 40 minutes of activities with them. I then took a second group of children and we did a completely different set of activities with them, just on moving around, partnering up, greater and smaller, sitting in order. And what we did eventually, which was one of the most fun activities I've had in the past 12 months, was we actually got the children. I got a group of 6 children and we created the entire 120 grid from using the tiles. Basically, we gave each of the children a set of tiles at the start. I laid a few out as a starting point, and the children went and, you know, over the course of probably about 10 to 15 minutes, built up that whole picture of a 120 grid using the place value. Really, really solid activity that really took them to greater depth. So what we've looked at so far is, first of all, lots of ways of arranging base 10. And as I say, we'll move on at the end of this session just to that 5 and a bit structure. What we've then looked at is that consistent way, if we are looking at comparing the numeral with the actual amount using the base 10 tiles, similar to the number board yesterday. I'm going to take that into an idea that I've used a lot over the past few years, asking children to start with the number and create it in that particular format, putting the 10s together and the 1s together. As I've said, I would not normally do that, and when I'm doing calculation activities and the majority of my place value activities, I space them out so the number is much easier to see. But for the purpose of this activity, I'm actually saying to the children, I'd like you to put the 10s together, I'd like you to put the 1s together. So let's look at some of the numbers. We can see 48, 33, 88, 55, 12, and 64. But what I want to do now is ask them to bring into play 100. And to actually, this time, use the 100 as a template on which you put the other colours. So, and the other amounts. So I'm going to put the 10s on top of the 100, like so, and I'm going to put the 1s on top of the 100 there. And what we actually see then is, yes, we're seeing, as before, the 6 10s and the 4 1s. As we've got on the reasoning card, we've got the 6 10s and the 4 1s on here. But now, because we've put them on the 100 template, it's no longer just 6 10s and 4 1s with no relation to 100. It's got a relation to 70. As we can see, what we can now see is we can see there's 64. And just like on the abacus yesterday, 10, 20, 36 will get us to 100. It gives us a better picture of the number. Again, if I take the same idea of the 100 square and put the 8 10s and 8 1s on there, again, what I would normally do if I was arranging them, I would normally arrange them that way with the 50 and the 30 and the 5 and the 3. But for the purpose of this activity, I want them all together, and we'll put them onto the 100. Oops, we'll put them onto the 100 template. There's the 8 10s. Why did I choose 88? It's a much harder number to put on, but there's my 8 10s. I'm going to put the 8 1s on. You can buy base 10 as well that does join together, which makes this activity slightly easier. But just for speed, it's a little bit quicker just doing it like this. There we go. And there we see it. I'm going to put that up back over there. On the card, 8 10s and 8 1s with 2 more to make 90. On the template, 8 10s and 8 1s. I know the number is 88, and I need another 12 to get me to 100. That brings me to, again, sometimes you do an activity and you don't realise the potential of it until you see it a different way. And it was probably about 18 months ago to 2 years ago when I was doing this activity with a group of children in the Midlands, and one child came up with something that I wasn't expecting. They'd done it slightly differently. And if you look now at the 33, or the 55, we'll take the 33. What the child had done is, he rather than set it out like the 48 over here, he'd done it that way. He'd put the 3 10s and 3 1s underneath. And the first thing he said to me as he was doing the activity, I'd started the whole day doing an abacus activity and making numbers with an abacus. And the child just said to me, "Mr. Reddy, it's just like your abacus." And I looked at it and thought, it's completely like the abacus. It's usually we see the number this way, kind of vertically. Setting it out this way made it very much like the abacus. But even more interesting was when we then set out the 3 10s and 3 1s on the template. What you've actually got now is a perfect representation of 100 square. Exactly where the number would be on 100 square. And it was that made me think, wow, I almost thought to myself, I've almost been doing this wrong for many, many years. When you can see it on 100 square, you start to think to yourself, that tells me something more about the number. It's still 3 10s and 3 1s, but I can see its position now. I can see, again, how close it is to 100, as I could before. But what I can also see is where it would appear on 100 square. That's exactly there where the number 33 would appear, rather than having it turned the other way. Again, the second I then turn this round here, what I've now got, I've still got the same number, 88. It's still 8 10s and 8 1s. Where will the number 88 be on 100 square? Here. This is what mastery is really about. Mastery is about not starting with this, with the 88 as a numeral, but starting with something practical, 8 10s and 8 1s. And then if we're looking at 100 square, what do we normally do with 100 square? You can just have a look at this. Let's find the number 88. And how often do you have children just looking for an 8 and an 8? You know, or where's the number 48? They're looking somewhere for a 4 and an 8 until they find a 48. they've not really got a sense of where the number is. They're just kind of, oh, it's 48, it's 4 and 8, it's where to, oh, there's the 4s, and there's the 8. That's not a really understanding 48. They're not really understanding anything about it. They're just finding it on a number square. Whereas 88, they're looking for 2 8s. What we're doing now is thinking, actually, where will 88 be? Let's look at it this way, and suddenly this is a far better way of doing it. Don't start with the numerals and look for a number. Actually start here, having already done this activity over here. So where is the number 88? Well, there's 8 10s and 8 1s. Where's that going to be on here? 8 10s and 8 1s. That's where the number 88 is going to be. Similar, we looked at 33. Where's number 33 going to be? I'll just bring that number here. So on a 100 square, let's not start with find 33. Where's my 3s? Here. And 1, 2, oh, it's there. Let's have a look. Where will 33 be? Well, what I'm going to do is I'm going to start with the concrete, which is here. 3 10s and 3 1s. That's the position of 33. Let's have a look on here. There's 3 10s and there's 3 1s. Far, far better. And then, or I'll just bring another 100 square into play. So I can go for the proper CPA approach of mastery. Concrete, 3 10s and 3 1s. Pictorial, 3 10s and 3 1s. Abstract, there's the number 33. But now it's got a real meaning as to where it should be. Those other numbers that we're looking at, where's 48? Once I've done this activity, I'm thinking, oh, 4 10s and 8 1s, it's there. Rather than looking for a 4 and looking for an 8. Where's number 64? Well, that's 1, 2, 3, 4, 5. There's 6 10s and there's 4 1s. There's where the number 64 will be. And again, as we can prove with this number here, if I just turn the number 64 around, that's exactly where the 64 will be. 6 10s and 4 1s. You can even use multi-link cubes, and the multi-link cubes, interestingly, are the perfect size to fit on a standard 100 square. 10, 20, 30, 40, 50, 60, there's my 6 10s, and there's my 4 1s, 64. Let's have a look where 64 is. 6 10s and 4 1s, 6 10s and 4 1s. Let's have a look over here, 64. That way, you're giving children the understanding of a number rather than just expecting them to find a numeral without any concrete meaning. Let's go concrete, let's go to pictorial, and let's finally move into the abstract.
And that's it for the first video today. Please take a look at video 2 if you get the chance, which looks at the idea of 5 and a bit in a lot more depth, using different resources and also accessing quite a few of the other images from the sense of number place value wall charts. So please check those out. If not, then it will be really good to see you again tomorrow for day 5. On day 5, what we're going to be looking at is partitioning numbers in different ways. So again, quite more developing into the greater depth idea of what place value is all about. Thank you very much, and I'll see you all again tomorrow.